Okay, so now you've kind of had a lot of examples of how do you calculate the area under a normal distribution curve around either a value or two values of x. Let's kind of apply that to some problems. So let's look at an example. So the final exam scores in a statistics class were normally distributed with a mean of 63 and a standard deviation of 5. Okay, part A says find the probability that a randomly selected student scored more than 65 on the exam. So if you're kind of uncertain as far as where to go or what to do, the first thing you can do is always just draw the distribution itself. Okay. Um, and also put down what given information that you have. Okay. So let's actually start with the given information. So we know that we're dealing with a normal distribution. All right. And it has a mean of 63 and a standard deviation of 5. All right. So we've got a normal distribution with a mean of 63 and a standard deviation of 5. All right. Let's draw this out. Let's see what this would look like. Get some practice drawing a normal distribution. Again, I'm not grading your art. Okay. So there's something that looks somewhat bell-shaped, not really symmetric, but hey, it's a try. It's an effort. Okay, and so the mean is 63. Okay, that's our mean. And let's put a few standard deviations in. So one standard deviation up. So we're going to add 5 to that. So that'll be 68. And if we do that again, we add 5 more. That'll be 73. And if we subtract 5, that'll be 58. And if we subtract 5 again, that'll be 53. Right? Now, so already we've got quite a bit to go on just by drawing what we've been given. Now, what is this problem asking for? Find the probability. So when you say find the probability, immediately you should think of area. Probability is area. That a randomly selected student, so that's a value of x, scored more than 65. So this more than is going to tell us on which side of 65 we want the area to be. All right. Well, let's translate this into a probability expression. So find the probability that a randomly selected student scored more than 65. We want to know what that is. So let's find 65 on this distribution. So 65 is greater than 63 and less than 68. So 65 is going to be somewhere right here. And what we want, oh, let's see here. I'm starting to shade the wrong area, aren't I? Because we want the area where values of x are greater than 65. That's going to be on this side, right? Now, if we want the area to the right of 65, what do we expect the answer to be? Well, I think it's safe to say that we expect this answer to be less than 50%, right? Because the area on one side of the mean is 50%. And so the area that we're looking for should be less than that. So that gives us kind of a check that when we calculate our answer, we can at least just check and see if it's less than 50%. Is it what we expect? Okay. So that serves as a helpful check. Now, with examples, what I tried to do in my lecture notes is to provide screenshots of the actual calculator functions that you're supposed to use with this example. Now, when you do think pair shares, um, generally I take those screenshots away to try and promote or provoke your memory. Do you remember what functions you're supposed to use and what values you're supposed to put in? Okay. So if you're using the Texas Instruments calculator, you want to use normal CDF. So what's going to be the lower value? Well, the lower value is going to be 65. The upper value is going to be positive infinity. So you're going to put E99. We have a mean of 63 and a standard deviation of 5. With the NumWorks calculator, we have a mean of 63, a standard deviation of 5, and we want the area to the right, so you'll use this option. And we want values of x that are greater than 65, like that. And let me go ahead and just use maybe the NumWorks calculator for that one, just because it's more visual. Go to normal. All right, so we have a mean of 63, standard deviation of 5. And we want the area to the right. And we want it to the right of 65. So that looks like here's 65. This is the area to the right. So it's about 34.46% or 34.5% roughly. So the probability that a randomly selected student has a score greater than 65 is equal to 34.5%. All right. Let's see, that came out to 0.345, rounded to 3 decimal digits. Now compare this to what we expected. We expected it to be less than 0.5 or less than a half, and it was. Okay, so that should give us some confidence about this answer. All right, let's look at the next part. So find the probability that a randomly selected student scored less than 85. All right, so we can redraw this picture. So that's always helpful. Again, the more times you draw it, the more you're putting this shape into your brain. And you'll be able to kind of draw this shape out in your brain the more times you actually do it in person. All right. There we go. And what are we looking for here? Find the probability a randomly selected student scored less than 85. So the probability that a randomly selected student scored less than 85. All right, so 85, actually, I need to keep building this out. So if we go one more standard deviation up, so we're going to add 5. That should be 78. Oh boy. Add 5 again. It's going to be 83. Add 5 again. 88. Okay. So This is the mean plus 1 standard deviation. This is the mean plus 2, the mean plus 3, the mean plus 4. This is 5 standard deviations out. And 85 is right about here. So we want the probability that x is less than 85. So we want everything to the left of it. We want that area. All right, so what do we expect? Well, certainly this probability, that certainly should be greater than half. Okay, this is what we expect. Certainly greater than half. All right, it's way over to the side. But let me also make you recall the empirical rule. So the empirical rule said that within -3 and +3, so within 3 standard deviations of the mean, that this area from here to here was 99.7%. So just between 3 standard deviations, we had an area of 99.7%. Well, our value of 85 is way out here between 4 and 5 standard deviations, between 4 and 5 standard deviations away from the mean. So actually, this probability should be greater than even 0.997. It should be even larger than that. So this is really useful to know what we expect our answer to be. This shows, a higher level of thought, critical thinking. And this way you don't treat your calculator as just some black box and you punch numbers in. Check and see if those numbers actually make sense within the context of your problem. All right. So with the Texas Instruments calculator, with this one, we're going to have a lower bound of -E99 with an upper bound of 85, with a mean of 63 and a standard deviation of 5. And with the NumWorks calculator, we want the area to the left. So we want values of x that are less than 85, and I forgot to put a mean of 63 and a standard deviation of 5. All right, and let's go ahead and just go over to our NumWorks calculator. And we got the same values. Let me change the area to be to the left of, and we want to the left of 85. And look at that. So point, we got 5 nines and 4 6. So 5 nines and 4 6. So let's come back over. So this probability is equal to 0.5946. Is this probability that we calculated what we expect? Yeah, we expected it to be greater than half, which it clearly is. And we even expected it to be greater than 0.997. And this is greater than 0.997. In fact, this is 99.99946%. That's a really large probability. Okay, so this is an example of calculating probability by calculating the area under the normal distribution curve of data from final exam scores. And I've demonstrated, how to do it with both calculators. Okay, let me know if you have any questions.